Very good morning to all. So we are to discuss yet another topic from the manufacturing process, the last module, that is the extrusion, rolling and forging. So these are categorized in a metal forming process, so which applies some force to deform the metal to the required shape. So what is the objective of this session? First we will see the introduction to extrusion, followed by the classification of extrusion, how it is classified, and finally we will discuss the advantages and disadvantages of extrusion, and similarly we will study rolling also, introduction to rolling, classification of rolling and its advantages and disadvantages, and finally we have forging. Forging also we have to cover the classification and advantages and disadvantages. So let's start our session with the extrusion. So what is extrusion? Have you ever applied this in your real life? The answer is yes. So you might have seen this. You are making a jalebi with the help of particular mixture passing through a small opening, and if you apply pressure here, this mixture will flow in the shape of that opening. So similar thing happens if you are putting a melange in your hand. You are forcing this end of the melange mixture, it will come out in the shape of the opening here. So this can be applied to metals also. If you are compressing or pressing a metal block, and if it is free to flow through an opening in the other end, it will come in the shape of the opening. So that is what we are doing in extrusion. So here you can see this is a metal block known as billet, and we will be pressurizing this metal block, and here in the other end we have an opening, and the metal will come out in the form of that opening or in the shape of that opening. So that is extrusion. So extrusion means it's a metal forming process to form the products of uniform cross section in required length. So in extrusion we will get a uniform cross section products like bars, cylindrical rods or rectangular bar, etc. And what we are doing is, in extrusion, a metal block known as a billet is forced to pass through a die opening. So we require a die, and an opening should be there in the die, and the metal is passed through that die opening. And this thing we already know, the cross section of the product will be identical to the die opening. And how to compress the metal? We require a very large force to compress the metal block because it is in solid state or semi-solid state. So you require a large force, not like a liquid. So we get the help from hydraulic press or a mechanical press, etc. So you require a press for achieving this compression. It can be drive either hydraulically or mechanically. And if the extrusion is carried out at very high temperature, that is 50 to 75% melting point of that metal, it is known as hot extrusion. So we can do it at the high temperature. Before extrusion, if you are heating the billet near this temperature, that is, it is less than melting point, but it is above the recrystallization temperature of the metal. It is known as hot extrusion. And if it is carried out at low temperature, around room temperature only, it is known as cold extrusion. So we can carry out extrusion either in hot condition or cold condition. Then extrusion is generally employed for the manufacture of solid and hollow parts. So we can manufacture hollow parts also, but it should be uniform cross section. And it is mainly applied to non-ferrous metals, that is ductile metals like aluminum, copper, tin, lead, etc. So non-ferrous metals we can work with this extrusion, and also certain steel products we can shape by extrusion. Then now to classify extrusion, so we have only two major classification of extrusion, that is direct extrusion and indirect extrusion. So let's see what is the difference between these two types of extrusion. So let's see what are the difference between direct extrusion and indirect extrusion. So this is a figure of direct extrusion and this is indirect extrusion. So can you point out some difference between these? The first difference is here we are applying force in this direction from right to left, or the ram is moving from right to left. So the ram is a cylinder used to press this billet. This red color one is the billet. Here it is the billet. Here this is the ram. This blue color one is the die. So in direct extrusion, the application of force or the movement of ram and the movement of extruded part are in same direction. That is why it is known as direct extrusion. So you can follow this arrow here. Both are same direction. But what about this indirect extrusion? We are applying force from right to left through the movement of this, but the extruded part is moving opposite to that. So it is moving from left to right. So this arrow, so that means this opposite. So that is the major difference. So first difference is that the movement of ram and the extruded part is in same direction in direct extrusion, but movement of ram and extruded part is in opposite direction in indirect extrusion. Then another difference, in direct extrusion we are using a solid ram. So you can see here the ram is a solid cylinder. But what about here in indirect extrusion? It is a hollow ram, because the extruded part has to come through the hole of this ram. So it should come through the central hole of this ram. So it should be hollow. That is the second difference. And another important difference you can see in direct extrusion, what is moving and what is stationary. The billet, this one, the billet is moving. So we are pressing the billet towards from right to left. And die is stationary. This blue color die will be always here. It remains stationary. But what about indirect extrusion? This one. So here the billet cannot be moved because this end is closed with the help of this plate. So here the billet is stationary, but this blue color die is attached to the ram, so it can move. So that is another difference. In direct extrusion, billet moves and die remains stationary, but in indirect extrusion, billet is stationary and the die is moving. So which one will have more friction? Can you predict among these two which one will have more friction? Of course the indirect extrusion, because in direct extrusion friction will come between parts which are relatively in motion. So in direct extrusion the billet is moving, this large block of billet is moving, so it requires more friction. But in indirect extrusion the billet is not moving, instead this small die is moving. So we can less friction exists, so power required is less. So that is the another major difference. Friction is high in direct extrusion and it is less in indirect extrusion, so require less power. And another difference, in direct extrusion you can apply high loads, heavy loads you can apply because of the, but in indirect extrusion this ram is hollow, so you cannot apply a very high load because it will result in this breaking of die or ram, etc. So another difference, that is another difference. High load we can apply in direct extrusion, but in that extrusion we cannot apply that much load. So this is a very important topic. So if it is asked, we have to draw a neat figure of this direct extrusion and indirect extrusion, mark billet, die, the movement of the ram and extruded part, etc., and identify this difference. So to understand more about extrusion, you can find out several animation videos in YouTube. So this is one of that. So you can find few animations like this. So here this is the actual figure or actual representation of extrusion. This is the ram which is moving. So ram is a cylinder that press this billet. This is a billet, and this is the extruded part coming through that after extrusion. So this is the animation of what happens. So we are compressing this billet. So you can see here, and it comes out through the die opening. So we are applying a huge compressive force to the billet and pressing it and molding it or shaping it to that particular die opening. So you can similarly you can use different types of video like this. So next we are going to the advantage and disadvantage of extrusion. The first advantage is a continuous process. So extrusion is a continuous process, that is advantage. High production volume. We can produce very high production volumes in extrusion. Then already we have discussed different types of metals, non-ferrous metals like aluminum, lead, tin, etc., as well as steel. All these can be handled by extrusion, and its operation cost is relatively less compared to casting or other manufacturing process. This operation cost is low, and we will get a good dimensional accuracy. So all the metal forming exercise, that is extrusion, rolling and forging, we will get a good dimensional accuracy compared to casting, because casting we will have that dimensional error because of the solidification of the molten metal. But here we are not melting the metal, but we are shaping it with the help of a force, so the dimensional accuracy will be good. But disadvantage, the complex shapes cannot be produced. We can see only uniform cross-sectional shapes can be produced by extrusion. And another thing, proper lubrication is needed. So we have to continuously lubricate the billet as well as the die, etc., to get the good surface finish. And already in that video you can see that speed is very low. So compared to rolling, etc., the extrusion speed is low. So we will study rolling in the coming slides, so you will be more clear about that. So that is another disadvantage. Now what is rolling? So rolling also we have applied in real life. Let's like making a chapati. So you are compressing a solid chapati with the help of this tool, and what you are doing is you are rolling from above the surface of this, and we will get a very thin sheet of chapati. So like that, this is what happening in rolling. This is a 2-roll mill, so we are using a 2 rolls like this, and a metal block or a metal sheet is passed in between the gap of these 2 rolls. So due to that compressive force, this will be shaped into a thin sheet. So that is happening in rolling. So rolling is a metal forming process in which the metal is shaped into desired shape by passing the metal in between a pair of rolls rotating in opposite directions. So 2 adjacent rolls will be operating in a opposite direction at the same speed. the roll squeeze the metal and reduce its cross section, and its length will be increasing. And here also we can have hot rolling as well as cold rolling. Hot rolling, the metal will be fed into the roll which is heated above the recrystallization temperature. So recrystallization temperature will be below melting point, but we require some temperature in hot rolling. But if it is in cold rolling, it will be below recrystallization temperature, or it will be at room temperature mostly. So we can use hot rolling as well as cold rolling. And bar, plates, sheets, rail, etc. can be made by rolling. Then rolling, we have more number of classification based on the number of rolls and their arrangement. We can classify rolling into a number of categories: 2 high roll mill, 3 high rolling mill, 4 high rolling mill. All these are based on the number of rolls used. And we have 2 more, that is cluster mill and planetary mill. So let's see what are these. Quickly go through this because just you have to draw that figure and tell something about that. So this is the classification, the figure of these 5 classification. So let's see one by one. First we have 2 high roll mills. So this is the easiest of this classification. We are using only 2 rolls which will be rotating in opposite direction, and we will feed the metal workpiece in this direction, and we will get a thin sheet because of the application of the pressure. So 2 high roll consists of 2 heavy rolls placed one over the other, and normally this lower roll will be fixed stationary and the upper roll can be moved. So we can move this upper roll up and down, and the gap between these can be adjusted like that. Both the rolls rotate in same speed in opposite direction, and they are controlled by high power electrical motors, and the workpiece is fed to the roll in one direction. So that is what happening in 2 high roll mill. Then what about 3 high rolling mill? We are using 3 rollers like this. So any of the 2 rolls will rotate, the nearby rolls will be rotating in opposite direction. So you can see here the upper roll and the middle roll rotates opposite, and again the middle roll and lower roll rotates opposite. So 3 high roll consists of 3 rolls positions one above the other. The upper and lower roll rotates in opposite direction, and similarly middle roll rotates in the opposite direction. So the any 2 adjacent roll, if you take, they are rotating in the opposite direction. So upper and middle roll opposite, the middle and lower are opposite. Then here the middle roll is stationary, and we can move this upper and lower roll up and down to adjust the gap between these 2. The advantage is, first we can pass the workpiece through this upper and middle roll in this direction. Then again we can pass the deformed sheet back to the middle and lower roll in the second pass. So like that we can pass 2 passes allowed in this arrangement. So we can first pass the workpiece between the upper and middle roll. Its the area reduces. Again we can feed that continuously to this between the lower and middle roll. So that is one of the advantage of this 3 high roll mill. 2 pass we can go, and it eliminates the transportation of material from one side to other when one pass is completed. So if it is compared to 2 high roll mill, we have to, if we want to reduce more size, we have to once again pass it through that roll. But in this case it is not required. We can go for a 2 pass in this 3 high roll mill. Now what about 4 high roll mills? So here we have 4 roll mills, but only we have 2 working rolls. These are only the backup rolls, large size, used to support this roll. They don't have any roll in this pressing, direct pressing of this metal. So it consists of 4 rolls, which are 2 are working rolls, 2 are backup rolls. The working rolls as well as the backup rolls rotate in opposite direction. So you can see here the 2 working rolls are opposite direction and the 2 backup rolls are opposite direction. And generally the backup rolls are larger in diameter and they are used to prevent the deflection of working rolls. So they are used for a support on there to avoid the deflection of these working rolls. Now another arrangement we are using is cluster rolling mill. So this is a figure of cluster rolling mill. You can see here. Here the working roll is only 2, but it is supported by more than 1. Here we have 2 backup rolls. So instead of 1 backup roll in 4 high roll, here we are using a cluster of backup rolls. So that is why it is known as cluster mills. So it is used for making very thin sheet or foils. Consists of a pair of working rolls of very small diameter rotating in opposite direction. And the working rolls are supported by a number of backup rolls on either side. Then finally we have planetary rolling mill, which is entirely different from all these 4. So you can see here the backup roll is surrounded by a set of working rolls. So you can see here this is the backup roll, a larger diameter both sides, which rotates in opposite direction, and it is surrounded by a number of working rolls, small working rolls. That is why it is known as a planetary rolling mill. So it consists of a number of smaller working rolls arranged around the periphery of larger backup roll. And it can produce very thin sheet compared to other rolls. So this is a classification about rolling. So you have to only draw the figure neatly, then just explain how this rolling takes place in each category. Now similar to extrusion also, we can find several videos in rolling from YouTube. So this is a video like that. So this is a roller used. This is our billet. The billet is passed through the gap between the roller. So normally the lower roll is fixed, the upper roll we can adjust the height. So due to the compressive force, it's shaped into thin sheets. So this is an animation showing how that grains are. So instead a very solid, we have a grain structure of that metal. So that grain is more arranged by rolling. So recrystallization takes place. So this is more arranged grain we will get by this rolling, and this is another example of cold rolling. So this is a 4 high roll. First one we have seen is a 2 high roll. This is a 4 high roll. We have a large backup rolls here and a smaller working roll. So already we have discussed the 4 high roll. So working roll presses this. The backup roll just help to support this working roll. So like this you can find a number of videos about rolling for the better understanding. Now we will go to the category. So before that, just discuss the advantages and disadvantages of rolling. What are the advantages of rolling? So first advantage is it reduces the consumption of raw materials. So the raw material required is very less in rolling. And again, just like extrusion, the surface finish is better. And this is another important point. Rolling increases the hardness and strength of metal because the grains are arranged in more orderly manner. It increases the hardness and strength of the metal. and also the porosity of the metal is minimized. So just to recollect, in casting, one of the problem or disadvantage is the product will have more porosity. It's a defect in casting. But here in rolling you can see this porosity is minimized by this compression of the roller. And disadvantage is the process control is difficult because you have to use a very good quality electrical motor to control the speed and force of the roller. And another disadvantage, only ductile material can be effectively rolled. So you want a ductile material like aluminum for effective rolling. And overworking of rolling or more rolling will cause the brittleness of metal. So brittleness is the rupture or the fractional deformation of the material without any elongation. So brittleness of the metal will increase due to the frequent rolling. And the last one is heat treatment is frequently required to eliminate the residual stress in rolling. So these are the advantages and disadvantages of rolling. Now finally we are going to forging. So this you might have done in your workshop in smithy. So just like this, you might have placed a metal bar or a rod in anvil, and you, instead of the press, you might have used a hammer to forge this into the required shape. So what is forging? Forging is a metal forming process in which a metal or alloys are deformed to the required shape by applying a continuous compressive force from a hammer, or it can be from a die or a press also. So we require a continuous compressive force, not like extrusion or rolling. We have to frequently hammer this in forging. Continuous repeated compressive force is required. And here also you can carry it out in hot forging as well as cold forging. Mostly we will use hot forging because if it is hot forging we can easily deform the metal block. So in hot forging the workpiece has to be heated in the furnace before doing the forging. And if it is done at room temperature or at a lower temperature, it is known as cold forging. And normally the raw material used is large square or round bars. So you can see here it is a rectangular bar. And the classification of forging is only two categories. One is open die forging and closed die forging. And they are normally used to manufacture bolt, spanners, crankshaft of the engine, crane hooks, etc. So these are the some products that comes after forging. Now let's go to this classification of forging, that is open die forging and closed die forging. So let's discuss open die forging. So what is happening in open die forging? So we are using a two dies here, top die and bottom die. So they are flat. You can see here the shape is flat. And we will press this top die with the help of a press. And the metal is free to flow in this direction. So that is why it is known as open die forging. The die is open. It is not engrossing the metal. And this can be also done with the help of hammer also. So in open forging, the die do not encircle the workpiece. In closed forging, you can see it encircle the workpiece, but here it is not encircling the workpiece. And the workpiece is free to flow when contacted by the die. And the die used are particularly flat in profile. So you can see the top and bottom die are flat in profile. And the normal smith forging is an open die forging. So you have done this open die forging in your workshop, in which the workpiece is placed on a stationary anvil and a hammer is used to strike. Now what is closed die forging? So this is a figure of closed die forging. So you can see here in this die is not flat, but instead die formed in the shape of a cavity. And the metal is enclosed in the cavity. It is not free to move in this direction in the like that of open die forging. That is the main difference in open die forging and closed die forging. So in cold closed die forging, the metal is placed in a die that resembles a mold. So in casting, you have studied the what is a mold. So similar to that, here the die is having a cavity. That's why it resembles a mold. The other half of the die is connected to the press or hammer. Then that hammer is released onto the workpiece, initiating the metal to flow and seal the die cavities. A hammer can be dropped numerous times based on the dimension of the part. So here we will have this is the hammer here, or the press, which is used to drop the top die over the metal. The bottom die is not moving, it is resting on the anvil. And here the additional metal passed out of the die cavity develops a flash state. So small part of metal will be moving through this small gap, and it develops a flash state which cools off immediately and prevents the development of additional flash. So flash means by this strong force, the small part of the metal will try to escape through this small gap, whatever is here, but it will cool rapidly and it will prevent the movement of further metal. So this we can remove later. So that is about closed die forging. Now we can see similar to
Forging
the other
is the controlled deformation of metal into specific shapes
about
by the
forging.
use of
Also we can
compressive
find
forces.
several videos.
These forces
from
are applied
YouTube.
through tools and
So this is
dies,
what
driven
forging
mainly
is.
by hammers,
So you
which
are
deform the
placing the
workpiece by
workpiece in
high
an anvil
velocity
and
impact,
pressing it with
or
the help of
presses,
hammer,
which
so
deform
it
the
is a very
workpiece through
huge hammer
controlled
or
high pressures.
controlled by some motor or
Forging is one of the
hydraulic
oldest
mechanism.
metalworking processes,
And we have
dating
to,
as far back
so the
as
worker must
8000
be a skilled
BC.
labor. The worker has to
It is
continuously
utilized today to reduce the
place this
cross-section,
in different locations.
improve the metallurgical microstructure,
So
provide
this is a
directional
normal
grain flow, and
hammering.
eliminate
This is
porosity
the
of
hammering
cast
or the
ingot
forging of a
in
circular
fabricating
section.
wrought mill forms, and to form
So
discrete
all these
parts
are hot
to near
forging
net
because
shape
it is
from these
heated
wrought mill
from
forms,
the furnace. Then
further
only we
refining
are
microstructure
forging
and
the
directional
parts.
grain flow. Because of these
So like this
effects
we
on
can find a number
microstructure
of
and grain
videos
flow, the
about
mechanical
forging.
performance of wrought mill
All
forms
these
and
are hot
parts
forging.
is typically superior to that of cast metals. Open die forging is performed on ingot, billet, bar, or a preform,
So you are applying a
and is the
frequent
deformation of a
compressive force,
workpiece
not a continuous
between
compressive
flat
force
or
in this.
shaped dies without completely restricting metal flow.
So
This
see, you can
deformation
have the
can
spanner
result
is
in
made with the
lengthening
help
of the
forging.
workpiece, while
This is
reducing
closed
its
die forging.
cross-section,
This is what we are talking, the flash.
upsetting regions
Small
along
part
the
of the
length
metal
to
will
greater
try to
sizes than
move through
adjacent
this
regions,
die,
or
opening
bulging
in
the
closed die
workpiece's
forging, but
cross-section
it
while
solidifies
reducing its
quickly.
length.
That is known as a flash.
Lengthening and upsetting are typically done using multiple impacts, as the workpiece is incrementally advanced lengthwise
Now we will see
and
what
rotated about its longitudinal axis. There is essentially no limit to the size of forgings that can be made using open die forging. They can range from a few centimeters to 30 meters in length and weigh from a few to up to several 100,000 kilograms. Although fairly complex shapes can be made using open die forging, most are rather simple solids or hollows requiring considerable machining to achieve final shape. Forgings are produced using simple flat, V-shaped, or semi-round dies. Various accessory tools are also used, including saddles, blocks, rings, mandrels, and punches. To withstand forging temperatures, abrasion, and impact, dies and accessory tools are usually made of hot work tool steels or medium carbon alloy steels. Impression die forging, also called closed die forging, is the deformation of metal at forging temperature within one or more die impressions or cavities. It is performed both in presses and hammers. Workpieces may be round or rectangular in cross-section or flat discs, and the dies are sometimes integrally heated to minimize chilling and cooling of the workpiece. For simple shapes, impression die forging can be performed in a single press stroke. More often, however, several strokes of different force are used with dies having several impressions for sequential preforming and finish forging operations. Preforming operations may include edging to increase the workpiece cross-section, blocking to refine the shape for finish forging, and finish forging to complete the shape. In finish forging, the bulk of the metal is forced into the impression, while a thin layer, called flash, flows out between the dies at the parting plane, surrounding the forging. Flash comprises a flat region called the land, and sometimes a bulbous region at the end of the land created by a gutter in the upper die. The thin flash cools rapidly, increasing pressure within the impression, which assists metal flow in the impression details. Once finish forging is complete, the flash is removed either manually or with trimming dies.
Advantage and disadvantage of forging. The advantage is the forged parts are stronger than cast or machine parts. So if you make a product in casting or machining, it will have less strength compared to a forged part. And it gives better tensile strength. So you are applying a continuous compressive force, the product will have more tensile strength and toughness, and increased dimensional control compared to casting, etc. But disadvantage, you require high capital cost, because already you have seen this, a large hammer press is required. So to control that, we require a control mechanism, a prime mover is required. So all this will add to the cost of this. So high capital cost will be one disadvantage. Then skilled labors are required, because the workpiece has to place in different length and different sections continuously with the help of a labor. So skilled labors are required. And normally we will use hot forging only, but this requires a high temperature furnace. So that is a mandatory in forging, hot forging. And stronger tools are required. So all these are disadvantages of forging. So with this we will stop today's session about these three metal forming process.